Hi everyone, here is a video to help you with the transformations assignments. Transformations is its own unit because during the year it is on every unit throughout the semester. But for Delta Math, it was easier just to make it its own assignment because it can be done on all sorts of different function types. So you can see here's a quadratic, and then an absolute value, or no, sorry, square root, exponential, and the bottom one is absolute value. It doesn't matter which type of function you're working with, transformations act the same with all of them. So if you see this letter in the front, the a value, the number in the front, if it's negative, it tells you that it flips it over the x-axis. So if it's pointing up, it flips and it points down. Now the b value, which I always like to think of it as inside, the inside value, so you see how b is on the inside in all of them, moves the function left and right. Now the one caveat here is that it's opposite of what you would think. A minus sign moves it to the right, and a plus sign moves it to the left. Then lastly, on the outside, you can see this plus c at the end. That's going to move your function up and down. And that is exactly what you would think. A minus sign moves it down and a plus sign moves it up. So I would have this sheet or these notes handy somewhere while you're working so that you can reference them while you're working on the various assignments. So I'm going to go to my Delta Math page. Here you can see I didn't finish in my fake student account. I didn't finish that first assignment, so it's still here. It's still available for late credit. I can click on it and I can work on it. Remember, the highest score you can get from late credit is a 4.5, but that's still a really awesome score. So if you still need to do that, you can work on it. But here's our transformations assignment. This one is much shorter than last time. So here's level 1. And basically what they want you to do is look at this equation, and I'm going to actually do this right here together so that we can see them both. See my little note sheet. Look at this equation and then move the function to match that. So I have a minus 2 here on the inside. So the inside value moves it left and right. Minus 2 moves it to the right too. So I'm going to take this green dot and just move it straight to the right too. And submit. And there. So all you're doing is moving the graph to match the equation. Let's look at another one. So now this one, it's a cubic, but it's exactly the same as the types of functions over here. It's a plus 4 on the inside. So that means it moves to the left 4 because it's the opposite of what we would think. So I would move it to the left 4 and submit. And there. So let's see one more if we can get a up and down. Maybe these are all just left and right. So this one plus 4 again would be moving to the left 4. So that is the first problem type, level 1. Now if we look at level 2, this has 2 transformations. Still just moving the graph to match the transformation. So the x minus 1 is on the inside. So that moves it left and right. So minus 1 is going to move it right 1. Now I have a second transformation on the outside, the minus 5. That moves it down 5. So I'm going to also drag this down 5 spots. And that is where your new function belongs. I went to the right 1 and down 5. So you can see level 2 just takes it up a notch by having 2 transformations. So let's look at another one. So the number on the inside moves it left and right. So minus 1 moves it right 1. And the number on the outside plus 4 moves it up 4. So we go up 4. And there you have it, shifted right 1, up 4. Now let's look at the mixed level. So this is where the reflection is going to come in. That negative sign in the front reflects it, so it's going to flip. So you want to do the flip first and then the moving. It's a little easier. So I'm going to grab this blue point and flip it, bring it down. You want to make sure it was here at 1, 1, so you want to make it down here at 1, -1. Now that we've flipped it because of the negative in the front, the -5 on the inside moves it to the right 5. So I'm going to drag it to the right 5. So I flipped it and moved it right 5. So let's look at one more of those. So here I have a cube root function. It's not listed here, but it's exactly the same. This one actually only has a -3 on the outside, so that means we're going to move it down 3. That only had one transformation. Let's look at one more. So this one, I have a negative, so that means I'm going to flip it, and the +4 moves it up 4. So we're going to flip it first because of that negative in the front. You could also take this one and drag it up, doesn't matter. The bottom goes to the top, top comes to the bottom. So there I have flipped it because of the negative, and now I'm going to move it up 4 because of the +4 on the outside. So it was flipped and shifted up. So the first 3 types of questions are all pretty much the same. You're just looking at the function and moving it based on what it shows here. The last question is a little bit different. It gives you the solid graph, black one, which is the starting point, and then they want to know which equation is the dotted one. So if I look from this point here, to get to the new dotted one, I would have to go down 1, 2, 3, 4. So I know on the outside, it's going to be a -4. And I would also have to go to the right 1, 2, 3, 4. So I know on the inside, it's going to be, sorry, down 4 means outside is -4. To the right 4 means inside is also -4. So on the outside, I need the -4 to go down, and then to go to the right, I need the -4. So your answer would be this one here. So let's look at one more of those. So we're trying to go from the black one to the orange one. So first thing I see here is that it's been reflected over the x-axis. So you need a negative on the outside to have it flip. Now the question is, did it move to the left or to the right? So this, to go from black to dotted, move to the right 2. So you want it to have -2 on the inside. And then it's going to show you the animation of it being flipped and moved. So there you have it. That is how you do this today's transformation assignment. Remember, the goal is to get as much of this assignment done as possible. If you do complete it to 100% before class tomorrow, then you don't need to be in class. So good luck. Reach out if you have questions. I am here to help.